So once you've selected table, it should give you a blank table that looks something like this. And we're going to fill in 3 points, the x and y coordinates of a starting point, a middle point, and an end point of our projectile. Our projectile, our little foil ball, started with a distance of 0. It hadn't gone over any at all. So make sure your first x value is 0. Yeah?
I wasn't here on the day you guys did the table.
You might not be the only one. So let's see here. There were 3 numbers that we were going to come up with, and this is all you need are these 3 numbers to model this flight path. Since you weren't here, we'll just make something up. We can think of, maybe you got a chance to play with it, to see if it worked, and so you can estimate the average height. So that would be how high off the ground at the peak of the flight path. I'm just going to say 90. These are the numbers I'm going to use later. So this is the top of the notes. We can say it went 90. Oops, this is 4. I'm going to change it to 5 to be consistent. And that's just the distance from the ground up that our projectile is starting in the basket of the catapult. And then our average distance, I'm going to use the number 220. You can, if you didn't get it, you can put in any number from, 50 up to 400, whatever you think your catapult would have done. So starting with those 3 numbers, that'll give us everything we need. And those numbers, you would have taken them from right here. So my maximum height, I said, was 90. My distance was 220. And 5 was I would have filled in up there for my starting height. All right, so now, that was a good question, because I want to make sure that everybody is able to make use of this table. So 0, everybody should have, and then starting height was the same as our C value over here. So go ahead and type in that small distance from the ground to the bucket of your catapult. We're going to skip this maximum distance right now. What we mean is the distance when it's at its max height. What we do know is our max height. You can take this number. That's where you calculated maximum height, the average, and type that in right underneath your 5 in the Y column. While you're filling out your Y column, you might as well fill this in as 0. So our very last point that we're going to have, the projectile flies through the air, and then its height gets back to 0. That 0 right there means it hits the ground, and we're going to say the distance that it traveled for it to hit the ground. That's where I put my 220. That's where you would take whatever number you calculated as your average, and you would put it right there. We did not find the distance that it traveled to get to that maximum height. But this is a parabola. Parabolas are symmetrical, so it looks about the same on both sides. So if we take our full distance and we cut it in half and then go straight up, that should take us to our maximum. So this maximum distance, take your distance below it and divide it by 2. I'm going to take, in my case, 220, divide it by 2, and that gives me a maximum distance of 110. So go ahead and take this number, divide it by 2, and you'll have your maximum distance. It doesn't need to be exact. If your distance was a odd number, it doesn't cut in half nicely, you can round it up to the nearest whole number. Everybody got a good handle on this? Everybody got a starting point with 2 numbers, a middle point with 2 numbers, and an end point with 2 numbers? if you're not quite following along, I can come around and help you, but only after we get this last equation typed in. So you can click underneath of your table so that you can type in another equation. And I'm going to make one quick adjustment. You can do the same thing on your worksheet. I'm going to put little subscript, ones underneath the A, B's, and C's. If we just use A, B, and C, and you already used them for your slider, it's going to think that these are referring to the slider values when we want these to be whole new values. So you're going to need to type in ones underneath all of your letters as we're typing this in. So I'm going to grab my Desmos. And the last class, I already typed in my information, so I've got my table with my start, middle, and end. And if you click down below it, it gives you a place to type in your equation. And you don't need to press the shift minus to get a subscript. You just type y1, and it knows to put it below your y, so it says y sub 1. Instead of an equal, we're going to use that squiggly line called a tilde. It's on the very left upper side of your keyboard. Shift and then tilde gives you that squiggly line. And if we had an equal sign, we would be telling Desmos, hey, graph this for us. That tilde sign tells Desmos, hey, give us the equation. We don't know, but we know it matches these points. So after that, we got a A1 times Y1, and we're going to square that Y1. So after you type Y1, give yourself a shift 6. So you have your caret top. That sends you up into the exponent. Press 2, and then we're going to add. So shift equals is the plus sign. We're going to add our B term. So B1 times Y. I messed up, didn't I? Anybody tell what I messed up in the first term? The Y, right? What should that be? X. We already have our Y over here, and we want to put X's to insert in there. So sorry about that. Go back, change that Y to an X. The B also gets multiplied by X. Type X1. And then the last term has only one letter. What letter does it have? There's our C. And give it a subscript, C1. And you're done. As soon as you've typed this, then it calculates that line of best fit automatically. It created this black line here. Click it on and off. You can see which line I'm talking about. My table were those green dots. So it said, referring back to this table with X sub 1 and Y sub 1, I want to know the A, B, and C values that would create an equation that would be the best fit of those lines. So as soon as I did that and typed it, it gave me that line of best fit, and it's a really good fit. Better than I did, right? It goes right through those lines. So you're going to take these values. It says A sub 1, B sub 1, and C sub 1, and you're going to use those to create your final equation on the page. So the calculated function starts with an A sub 1. Once you've got your A sub 1, plug it in right there. It also tells you B sub 1 and C sub 1. And I'm going to make it so I can see mine. You can do some rounding. Negative 0.007 is what it told me mine was. 1.57 and 5. You should have different numbers. You're not copying my numbers down. You're copying the numbers from your Desmos from right here. So we have two different versions of the line of best fit. We've got the one that Desmos calculated, and we've got the one that you manually adjusted using the A and B sliders. My A and B sliders were at the top here, and I could have changed it a little bit to make it fit better. Oof. Make it go down a little bit more, and then increase it down maybe a little more, and increase it. And that's really close. Actually, those are really near the same numbers that I have for mine as Desmos calculated. When I had it before, I think I had it as a -0.008, and this was a 1.7. So these should be very similar. Of these functions. So it gives us the name of the function up here and the equation, and it has graphed it for us. We don't need the equation itself. We can pick out all of this stuff just by looking at the curve. So the first thing is our intervals of increase and decrease. What is an interval? There will be a middle involved. The middle might separate two intervals. Usually we think of interval as sections of time, right? If you're in track and you're running intervals, that might mean that you run for a minute slow, a minute medium, and a minute sprint, and do that over and over again. You've got intervals. And so here we're going to separate our x values of our function into intervals where it's increasing and intervals where it's decreasing. Both of these arrows say they're going down, right? So we might think it's just decreasing all over the place, except for when we're identifying this, we're always going left to right. So from left to right, this is going up. Give yourself an arrow there and write increasing. And then it keeps on going up, and then it hits some point up here, and then it starts going down, decreasing. We're going to use our axis of symmetry to cut up our intervals, to make sections where it's doing the two different things. So our axis of symmetry is right in the middle here, right? X equals 0 is our axis of symmetry. And so it asks first about increasing, interval of increase. We're going to write it so it looks kind of like a point where we put our lowest x value, and these are x values that we're looking at, and our highest x value in the interval, the section where it's increasing. What might our lowest x value, the furthest to the left, be in this side of the graph? Like if I follow this arrow, is it ever going to stop going left? Is it ever going to start going just straight down? If it goes straight down, then it's not a function, right? So this is never going to stop going to the left. So we're going to say negative infinity is our lowest value on this interval of increasing here, where the function is increasing. So we can go forever in that direction, but there is a certain point that we hit. What x value do we hit right here where it totally goes flat and it's not increasing anymore? Maybe that one. So that's our interval, saying we're going from negative infinity to 0. I don't like the way that they write these intervals. To me, that looks like a point, except for we cannot graph it because you cannot go to negative infinity. So But sometimes intervals are used. This kind of notation is used for intervals. So we're going to do the same thing with our decreasing. So we did our interval of increase. Now we're going to do decrease. What's the lowest number, the lowest x value on this side? We are going to be going to infinity. I'll go ahead and write that as the highest number. But we pick up on 0, right? We were increasing until we hit 0, and then we hit 0. So 0 to infinity is where we are decreasing. So from negative infinity to 0, it's going up. We hit 0, and then from 0 to positive infinity is our interval of decrease. It's going down. Domain and range are the next ones that we're going to figure out. Intervals, we're always talking about x values, but only one of these describes our possible x values. Which one of these, domain or range, refers to x values? Got a 50-50 chance. Hopefully some of you guys are kind of leaning this way. You're just feeling self-conscious about answering it. So whenever we're going to be using both domain and range, it usually lists domain first. And just like x comes before y, domain comes before range. In the alphabet, that's true. X comes before y, D comes before R. So we know that domain, whenever it's talking about domain, that is our possible x values. So we need to know our lowest x value, which we already kind of said, right? We know that this graph is going to go on to the left, and it's never going to get to a number. It's going to go on infinitely. Positive side, we already said as well. Positive infinity. And so we're just going to write this answer out. We're going to say all real numbers. We got the x values, all possible x values. We could have any x value from negative infinity to positive infinity. The y values is our range. What's our lowest y value that we could have? Which is kind of a trick question. Because this arrow, it never keeps going down, right?
Is it negative infinity?
Start with negative infinity, yes.
Oh my god, I'm so smart.
And I'm going to write it a little bit differently. We could write it out with a sentence. This is a bad sentence. All real numbers. Yeah, that's incomplete. But we could write it out in words. But mathematicians are lazy, so we like to use symbols. So we're going to say negative infinity is less than or equal to y. Domain or range talks about y. And then y is less than or equal to, take a look at this. And what's your highest possible y value on that graph?
Like 8.5 or negative 8.5.
Yeah, it's on the negative side, so it's going to be a negative number, and a little bit more than 8. Each one of these blocks is 2 units. I think it goes 8, 10, 12. So right in between, what's the number right in between 8 and 10? So negative 9. So let's go ahead and take a look at the second example. I want to make sure and give you guys one example where you have a downward facing U shape and one where you have an upward facing U shape when you guys are doing these on your own. That should be the first thing you look at, whether the problem you're working on has a regular U shape or a downward facing one. If it has regular, use this as an example. If it has the downward one, your answers are going to be very similar, just with different numbers to this example. So again, we don't care what the equation is. We're just taking a look at things. Best first step is to identify this line. What do we call this line? The line that cuts it right in half? That's yes, our axis of symmetry in this case is 2. X equals 2. And so we're going to, let's see here, we're going down on this side. We've got our interval of decrease over here and our interval of increase over here. Since starting off on the left side of the graph, it's going down, I'm going to start off with identifying my interval of decrease. I'm skipping that first one and going to the second one here. What do we write when there's not a number low enough that we can reach? No matter what negative number, there's always a bigger negative number. What are we going to write to start this off with? I'm never going to find a lower number. It's going to go for negative infinity. So my interval of decrease goes from negative infinity, and it keeps on decreasing until it hits what x value right here? 2. So there's my interval of decrease. Whenever you go from left to right on this, yeah. When we're done with the examples, if you go right now, then you're not going to know what we did here, right? And then you're not going to be able to have the example to help you on the notes. So that's why whenever I'm given instructions, if you ask, I'm assuming you're asking about the problem. But your answer is always going to be no. And usually I don't give all that time and to explain, but rather not interrupt, what we're doing here, because we went from negative infinity to 2, and then we can just pick up right with 2. So if you always start from the left, whatever number you ended up here is going to be the number you start off with here. So take that 2, put it here, and what's our highest number on the interval of increase? Infinity, right? Kind of a trick question. No highest number. It's going to increase forever. The next thing that we found was our domain, our x values. What do you suppose all of your possible x values are for this function? What's your lowest x value? Is that line ever going to stop going to the left? Same exact thing. In fact, all of your domains are going to be all real numbers. You could go over to your worksheet right now, and you can find where it says domain, and you can write all real numbers.
On all the domains?
On all of them, yeah. When we have an equation that is describing an actual situation, like with our catapult, then negatives made no sense. We weren't going to be launching our catapults backwards. And so our domain there was 0 to wherever it hit the ground. But there's no story around this. It's just pure math. And so we have an infinite coordinate plane, and we have infinite numbers in all directions. So all of your domains are going to be all real numbers. We'll go ahead and take a look. Last of all, very last thing, our range, possible y values. What's my lowest possible y value here? We're going down, down, down. We hit the lowest we have, which is 2, yes. So 2 is less than equal to y, which is less than or equal to some higher number. Do we hit a maximum? No maximum, so it goes on to positive infinity. So go ahead and take a look at these examples. Put them on the left side of your paper if you're right-handed. Put your worksheet on the right side, and make sure that the worksheet problem that you're looking at, you're using the same shape either a downward facing or you upward facing the same example that has the same shape. And you'll find that all of your infinities stay the same. You're just coming up with a new axis of symmetry to use for your intervals and a new minimum or maximum to use for your range.